Welcome to Brain Vision.
So now we're going to work on problem 43 from chapter 8. In this problem, we're asked to complete and balance several reactions. If we don't expect a reaction to occur, we should just write no reaction. So first here, we're given lithium iodide and barium sulfide. So we have lithium, Li aqueous, plus barium sulfide, aqueous. And the question is, does a reaction happen? So a reaction will only happen, in this case, if we form a new molecule, if something is solid. Because if all the ions are simply floating around in solution, we won't have a reaction. So we look at lithium sulfide, and lithium is always soluble, and barium iodide would also be soluble. And so we can say that there is no reaction. And this is because the potential products, when we switch the ions, are all soluble. So we can move to part B, where we're given potassium chloride and calcium sulfide. So again, we want to switch around the ions, and we see calcium chloride we know is soluble. Potassium sulfide is soluble because potassium is always soluble. So there's going to be no reaction here, and the reason is the same. Any of the potential products, when we mix and match the ions, would all be soluble. So we can move to part C, where we're given chromium bromate, CrBr2, aqueous, plus sodium carbonate, which is aqueous. So the question is, do we have a reaction here? So we know that sodium bromide will be soluble because sodium is always soluble. However, carbonate is almost always insoluble, and chromium is not an exception. So we're going to form CrCO3 solid. So we are going to have a reaction here. And then the other product will be sodium bromide aqueous. So now we can balance the reaction. We need two sodiums here because we have two here. We also have two bromates here. And so that's all that's necessary. So our final reaction is sodium hydroxide aqueous reacting with iron chloride. We know that both sodium hydroxide and iron chloride are soluble as they're aqueous solutions. And we know that sodium chloride is soluble, but iron hydroxide is actually insoluble, as most hydroxides are. So we have FeOH3 solid as a product, and then sodium chloride will be our other product, which we know is aqueous. Now we can balance our reaction. We need 3 chlorines here to match the 3 chlorines from the iron chloride. And then we'll need 3 sodiums to match the sodium and the hydroxide from the product side.